websites, even predominant websites that involved finding cross-site scripting through Swifts that load XML configuration files. So he was able to find vulnerabilities on Wall Street Journal and I think Facebook and PayPal, because he just started looking through the site for Swifts that load XML configuration files. In some cases, if you see Swifts that load other Swifts, Stefano DiPaolo at OWASP USA 2008 talked about a technique he called cross-site flashing, which is getting a trusted parent Swift to load a malicious child Swift, and then having that malicious child Swift be able to try to attack the parent web page. The thing that all of these things have in common is you're looking for Swifts which have flash vars that represent URL values. And by flash vars, what I mean is within the object tag, there's a parameter called flash vars, and then there's a series of values which get passed in. And flash vars are just a way to dynamically initiate a Swift based on the page load. So for instance, on finance.google.com, they have a Swift which shows you how the stock trended over the last 3 days. It's the same Swift no matter which stock symbol you give it. It's just when the page is loaded, the Swift is dynamically passed. Okay, I want the stock data for Symantec, or I want the stock data from Microsoft. And I haven't looked at finance.google.com to make sure that this is the way they do it. But one of the ways that they could do it is to be able to pass it in through a flash var. When they dynamically generate the HTML for the page, they would just write in for the flash var value the stock symbol that the Swift is supposed to load up when it first loads. So if you can find flash vars where var1 equals HTTP colon something, then that's going to be a Swift that's probably more likely to have cross-site scripting. It's not guaranteed, but it's typically a hint that you want to spend a little bit more time on that Swift than maybe other Swifts. And the reason being is that you can load a Swift directly in the browser without any surrounding HTML. So if you want to load the Swift on finance.google.com directly just by putting the URL for that Swift in your location bar, you could do that. Most browsers will generate a fake HTML page around the Swift to get it to load correctly. And then once the Swift is loaded, the browser assigns a DOM around the object the same way it would if you loaded it via an HTML page. So what that allows you to do is it allows you to take flash vars and manipulate them as though they were CGI variables. So if you've ever attacked a REST-based API just by changing the get variables around, looking for cross-site scripting, you can pretty much do the same technique with Flash. The flash vars, instead of being passed in via the HTML page, can be passed in as arguments to the Swift in the URL. So if you've got test.swift on example.org, you might try changing those HTTP colon URL values for JavaScript colon URLs. And that would result in cross-site scripting. You could point it to a malicious Swift on another server to see if you can do cross-site flashing, which Stefano described in his 2008 talk. And sometimes you also look for seeing if you can have the Swift behave as an open redirector. So if you wanted to conduct a phishing attack, you need a URL, you need to give the end user a URL of a site that they trust. So if the end user here trusted example.org, and I could get that Swift to redirect to phishing.example.org.example.com, some other website, then I might be able to use the Swift as an open redirector as part of a phishing attack. So those are some of the things that you tend to look for when you see Swifts that accept URL values. And for details about how to attack these, there's a blog written on client-side remote file inclusion in Flash. That one talks specifically about attacking Swifts which load XML config files. I mentioned already the talk by Stefano. And IBM also wrote a paper on Flash parameter injection, where they go through these techniques in deeper values. And like I said, all of these links are on the OWASP Flash Security Project website. So as long as you can jot down the titles, and you'll be able to find them later. And it goes into more detail about how you can do those attacks. Another thing that's sometimes useful for people, especially when they're learning, is if they can find example vulnerabilities, if they can find sites that have had this problem before in a realistic scenario. So one of the things that I linked to on the Flash security project is example vulnerabilities where Swifts have had these problems. So you can go and you can see attack strings that were used against production Swifts. So I linked to the original full disclosure post for the click tag attack. Rich Cannings in, I want to say late 2007, early 2008, found cross-site scripting vulnerabilities in 5 common Flash files. And some of those were actually Adobe's. But, so I linked to those there, so at least other people can learn from some of the mistakes that we made in our code for looking at them. And Jeremiah Grossman IBM had posted a talk about how to also look for cross-site scripting when you use external interface within Flash. So these are all good things to go and take a look at if you want to see attacks that have actually happened in the wild as sort of samples to supplement the reading that was there before. The Rich Cannings one is also good to look at because he talked, this vulnerabilities that he found in the Swifts were actually sort of library Swifts. They were Swifts that were included on tons of different websites. And that was part of the point of his research, was that you can find these, it's one vulnerable Swift, but you can find it on multiple websites because a lot of different websites use that Swift. And it brings up one of the challenges that organizations sometimes have with Swift content, and that is determining a version on it and keeping track of the version of the Swift. So being able to detect whether or not they've actually updated the Swift to the non-vulnerable version. So these are all good things to go and take a look at if you want to work with penetration testing. Some people like to take a look at the source for Flash. Some people aren't pen testers, they prefer to read code. The ActionScript language is an ECMAScript-based language, so it reads a lot like JavaScript. Therefore, if you already know how to read JavaScript, you should be able to get a feel for the language fairly quickly, at least as far as its syntax. And if you don't have the original source for the Swift, there are disassemblers out there which will convert Swifts back into bytecode. Or if you want an approximation of the source, there are decompilers that you can use. SwiftScan was a tool published by HP which can decompile ActionScript 2 and ActionScript 3. There's also Flare. Flare is a very popular one for people who deal primarily with ActionScript 2 Swifts. And then there are commercial versions of these as well that organizations use if they've lost the source to their Swifts. And just take a cross-site scripting vulnerability and sort of show you what it would look like on the inside. This is ActionScript 3. So let's say I have a Swift called nav to URL Swift that takes a URL. The loader_info.parameters, that's the object that holds all the Flash var values which got passed into the Swift at load time. So when Flash loads up, it takes a look at the surrounding HTML and says, okay, where are the Flash vars? It goes, it copies all of them, and puts it in loader_info.parameters, in the loader_info parameters object. And then it's up to the developer to go and retrieve whichever ones they were looking for. So in this example, it goes, it pulls the URL value out, and then without doing any data validation, it sends it to a function called navigate to URL. And navigate to URL is the function which tells the browser, okay, go navigate here. So if the navigate to URL request sends it to a JavaScript :URL, it's going to execute the JavaScript in the context of the hosting web page. Not the same way if you had JavaScript :links in HTML. The behavior is the same. If you're working with developers and you're trying to get them to adopt best practices as far as secure software design, there are different data validation libraries that you can refer people to. There's validators within the Flex SDK. So Flex is the language I told you about that's XML based. It has data validation libraries within it, so you can encourage developers to use those. There's also a Google Code project called Flash Validators. It's a set of data validation routines that have been written in ActionScript. So if you're trying to get a software development lifecycle, a security software development lifecycle deployed within your organization, and you're trying to get them to do data validation. They don't have to do it from scratch. There are some libraries out there which can help them. And also, if you're trying to set up secure software development within your organization, you can actually implement banned functions. If you're a C or C++ developer that's within an organization that has an SDL program, you're probably familiar with banned functions. Basically, you tell the developers that they can't use string copy, they have to use string copy underscore s or string end copy. And within Flash, there's a set of banned functions that you could deploy within your organization. Allow insecure domain is one of those. We put insecure in there for a reason. We wanted to let them know what they were doing was not ideal. Saying secure equals false to an cross-domain XML file. Setting security.exact settings to false. Basically, all of these, in one way or another, shut off security within the environment. So some of this information is also published as far as best practices go. So you can look for it, you can find it, and you can help encourage developers to steer away from these functions. And if you're doing a source code audit and you see these functions, it's a pretty good hint that they're doing something wrong or they're doing something they shouldn't. So these tend to be good things to grep for if you're just grepping through the source code. Now I understand that a lot of these functions I just rattled off, many of you may not recognize them, you're not ActionScript developers. But I wrote a paper called Creating More Secure Swiftable Web Applications. And in there, if you go to the very last page, I have information in there for people who do pen tests on a regular basis. There's an auditor checklist, a developer checklist, and I list all of the sensitive functions that you might want to pay attention to. So you don't have to understand all 120 or however many ActionScript APIs there are. There's a list of ones that say, just go through and look for these. These are the ones that you would probably be concerned about as a security auditor. As far as static analysis goes, doing it in an automated fashion, there's a tool called FlexPMD. It's a labs project at adobe.com, and it tries to find code quality issues. You might be, if you're familiar with Coverity, it might be similar in concept to Coverity, where Coverity looks for general code quality issues, but it can also look for security issues as a subset of that. FlexPMD is a similar tool. If you're a Flex developer, you can use it to search for general code quality issues, but there's also a couple security rules that we've been adding to them. And there's an update coming to it, hopefully fairly soon. I've got one of the developers inside of Adobe doing it for a security training project. There's this tool, SwiftScan, which was published by HP. This is good for auditors. Developers tend not to like it, at least in my experience, because it's there tends to be more false positives, and the rules are geared towards erring on caution. So it'll flag a lot of issues that are of interest to you if you're a security auditor, but they may not be of interest to you if you're the guy who actually wrote the code, because you already know what it does. So it will flag every time it sees the word password in the Swift. If you're a security auditor, you want to know everywhere it says password, because you're going to manually inspect each one of those lines of code. If you're the developer, you already know where it says password within the Swift. So you may not understand why it's flagging that for you. And then, of course, you want to make sure that the developers know that just because Swift is a binary format doesn't mean it's closed source. Anything you put into Swift is open to anybody with a free decompiler or disassembler. So make sure they're not storing passwords or crypto keys or anything like that in there. When HP released SwiftScan, Billy Hoffman published a video on YouTube called Billy Wins a Cheeseburger. And it's a funny 5-minute video if you have time to watch it, about him going through and decompiling a Swift game to obviously win a free cheeseburger. For the server side, Swifts do interact with the server side, so you shouldn't try to think about Flash security and generally in the bubble of it just being a little binary all unto itself. It does interact with the server, so you want to take a note and take a look at how it interacts with the server. Sometimes one of the things you have to watch out for is unintentionally supporting Flash content. Basically, this is if your sites allow uploads, end-user uploads. Obviously, anytime you're allowing end users to upload to your site, you want to be careful about what you let them upload.